Hello everyone, my name is Muhammad Anwar and today I want to present about my project which is IoT-InfraLab. IoT-InfraLab is an IoT simulation and cybersecurity lab that focus and try to help and provide a simple and free way for user or student to learn about IoT simulation and security using a virtual simulated device on your own computers. There is several problems students face when they try to learn about IoT system. It is quite expensive and to buy network equipment and IoT device. This provide a challenge to students. The second one is a learning barrier, where when they doesn't have equipment or space to learn about this, they doesn't have any hands-on experience to learn about IoT system. Last but not least, they have difficulty in maintenance. It's complex and require an expert to do maintenance on the real IoT system and equipment itself. This platform or system try to provide 4 features for the system. The first of all is we want to make that is zero hardware learning, where it doesn't need any real hardware for them to learn about IoT system. The second one is a threat sandbox, where they could simulate and do any real attack on the virtual network. The third feature is we want to give a real-time analytic which show the analytic of the IoT data and the alert from the attacks in a dashboard. And last but not least, the last feature is we want to teach the students to learn to use a real IoT frameworks that is used in the industry. So we have 4 objectives for this project. The first one is zero cost simulation, where user doesn't need to spend any real money. The second one is we want to make easy to control for the user sensors and attack simulation. The third one is we want to create a real-time security detection using a Suricata IDS. When attack is happening, it can detect the attack in real time. The last one is we want to teach students to familiarize themselves with the technology that usually used by the industry. The proposed solution is which is an IoT-InfraLab. That is we want to create a software-based solution which is a virtual software laboratory on the laptop, where user can run on their laptop, which everyone can use. The second one is we want to replace any physical equipment, IoT equipment, by using a Docker containers, which is lightweight and can host many containers on one laptop. The third one is we want to integrate a lot of open source IoT technology framework that is used by real industry, such as Node-RED, Mosquito, and Grafana. And fourth is we want to create a secure by design boundaries that is separate the design for the system for modular and safe to prevent any real attack on the host system, on the host device. Last but not least, we want to separate any sensors data and alert logs. We have 4 system module. The first module is sensor management and control module, which is to create, configure and manage any sensors container or node. The second one is the simulation module, where we want to simulate the IoT sensors containers and we want to simulate cyber attacks. The third one is a network security monitoring module, where this module will read the network traffic generated by IoT sensors and generate any security logs if detected. The last but not least is a performance visualization module, where it will visualize the data from the sensors and the alert log on the dashboard. We have several activities for each module. For simulation module, we focus on the sensors and the attacks. For the management module, we focus on the control and management of the sensors. As for the security module, we focus on implement the IDS to detect any attacks simulated by our system. And last but not least, a visualization module, where we try to visualize every data generated from this system, which is sensor data, and any alert from the attacks. System consists of 4 separate zones. This zone separation is to improve both security and organization. The first one is a trusted zone, where it contains main IoT service such as USB to Node. Second one is management zone, which handle containers and container management and system call function. The third one is intrusion detection system, which contains Suricata IDS that detect any attacks from the logs on the system. The last one is analytical zone, which store and visualize data using InfraLab and Grafana. By separating this into different zones, the platform remains safe and easy to manage. So there is several impact and benefit from the system. First of all, it is zero cost and accessible education for everyone. Where in the system, a student doesn't need to buy any expensive hardware because the system is able to run on standard laptop. The second one is safe and isolated as a sandbox, where any simulated attacks will not affect the host device because it is in isolation. And when attack is happen, we also can reset it with one click. The third one is we able to provide a hands-on experience to students when they learn using the real IoT technology, and they able to change the system itself using Node in the system. This number 4 is career readiness and industry. This project is able to help students to learn enterprise grade tools for their future careers, and this also able to teach them high demand job skill which involve IoT and security. Next is entrepreneurship opportunities. So we have 3 tiers, which is community, academic, and enterprise. Where the 3 tiers is for student and hobbies, which provide with some basic features such as 5 sensors, basic MING Stack, and attack change. So the second tier is academic, where it is for lecturers and research, where it have pre-made lab template and mass node scaling. And the last but not least is enterprise tier, which is for universities. They have automatic grading dashboard and multi-user cloud deployment. So the last is project demo, so we continue with demonstration. User is new and don't know what to do, they can activate this tower guide button to show them what each of the UI group does. So for example, we open this node management. It will explain what each of this field and the button does. Right now we want to show the node management, control and simulation. First, we will create a new sensor node, which is DHT11 that have temperature and humidity with the normal behavior. So we'll deploy without saving in the safe configuration. But deploy safe, we deploy and we save in the safe configuration. So the sensors is running in these active sensors, and we also can create our own sensor type such as this MP34. We add our own minimum and maximum value. We create, and here we will see the added sensor type. And from this safe configuration, we able to deploy this to use in the dashboard. And last but not least, we also can read the data generated from the sensors at here. So we can see the data, and if we want, we also can do summation on the sensor itself, such as we can pause, restart, and stop. And we also can stop on the sensor itself, such as we click on the kill containers. So it will stop one by one. With the security and attacks module and the attack function. So here this is the active network topology that we can see the IP address and the state. Here is the code security control, where we can change the mosquito config and the security Suricata rules and activate the auto attack isolation. So here we can do AI port vulnerability scan. So we just run it right now and wait for some time, and we will try to change this mosquito configs, and we will try to do attack from the attacker scripts. So when we see it should not show any log right now because the mod is currently vulnerable, no rules is implemented. So we change this, and here we can see that the result that give from this port vulnerability assessment, it show the IP and the port, the risk analysis and the recommendation. So we try again. The port scanning and thus is successful. Last one is the snip attack, where we try to read data from the sensors on the broker. So it is successful. Then we can see that all of three is detected and alerted. So here if we activate this button, it will automatically remove the attack node from the network. So the attacker node is already removed. So you can see that it is removed from the system. Continue with dashboard Grafana. So we have three dashboard here. First is IoT sensors, second is IoT platform health, last is security operations. So we can see operation of IoT sensors first. So IoT sensors have like number of sensors, the status, temperature graph, each sensor type graph, and the deep dive analysis, where when it above the threshold it will show red, and the latency of each sensors. So as for the platform help, this will show the CPU utilization, the memory, the system load, the each container usage, where we can see here the each container memory usage, each container network usage. And last but not least is this. We need to move the timers several times, and here we can see the attacks, the number of attacks, the alert, the attacks, and each what kind of attack happening at the time, the attack type distribution, where it shows the bar chart of each attacks, and the attack logs, where it shows the timing, the source and the destination, and what type of attack is happening. So that's all for me. Thank you.